Picture this. You're standing in the Mojave Desert, November 1959. A metal cylinder nicknamed Hot Rod sits on a launch platform. Then, bang, bang, bang. 6 explosions in sequence. The cylinder shoots 184 feet into the air, riding shockwaves like a cosmic pogo stick. This wasn't just another rocket test. This was humanity's proof that we could surf nuclear explosions to the stars. The masterminds behind it had a plan that would make Dr. Strangelove blush. Detonate between 800 and 1,000 atomic bombs beneath a massive steel plate to reach Saturn. They called it Project Orion. History remembers it as visionary, a dream murdered by treaties and politics. But declassified documents and the confessions of its own creators reveal something darker. This is the real account of how America's brightest minds almost turned nuclear Armageddon into a travel itinerary. The mathematics seduced them first. In 1955, deep in the classified vaults of Los Alamos, physicist Stanislaw Ulam, the same man who'd helped create the hydrogen bomb, scribbled equations that defied belief. Nuclear explosions, he calculated with mathematician Cornelius Everett, could propel a spacecraft with efficiency that made chemical rockets look like firecrackers. By 1958, this fever dream found its prophets. Ted Taylor, a nuclear weapons designer who'd birthed both the smallest and most devastating fission bombs America ever tested, understood atomic fury like a vintner knows wine. He'd created the 50-pound Davy Crockett warhead and the half-megaton super-oralloy bomb. Freeman Dyson, the theoretical physicist from Princeton who'd already unified quantum mechanics, brought academic legitimacy. Together at General Atomics in San Diego, they engineered the unthinkable. Picture their design: a massive steel plate, thick as a bank vault door, hanging beneath your spacecraft. Connect it with shock absorbers the size of buildings. Now, every second, toss a nuclear bomb out the back. Boom. The blast slams into the plate. The shock absorbers compress like God's own springs. The ship lurches forward. Repeat 1,000 times. The performance numbers seemed pulled from science fiction. Specific impulse. Think of it as your rocket's miles per gallon would hit 6,000 seconds. Chemical rockets? A pathetic 450. Imagine comparing a Formula One race car to a horse-drawn wagon, then multiply that difference by 10. A single Orion launch could hoist 1,600 tons to orbit. The mighty Saturn V that took us to the moon? It managed 140 tons, less than a tenth. Mars in 4 weeks instead of 9 months. Saturn's moons within a single human lifetime. Alpha Centauri, our nearest star, reachable in 130 years instead of 40,000. But this wasn't fantasy. On that November day in 1959, Hot Rod proved the concept with conventional explosives standing in for atomic bombs. 6 sequential blasts, 184 feet of altitude. The physics worked. The engineering was sound. So why aren't we commuting to Jupiter on nuclear explosions today? The answer came from Freeman Dyson himself, delivered in a calculation that would haunt him forever. In 1959, as Hot Rod validated their dreams, Dyson ran the numbers nobody wanted to see. Each Orion launch from Earth's surface would kill between 0.1 and 1 person worldwide from radioactive fallout. Let that sink in. Every single launch, a statistical death sentence for someone somewhere. Think of it this way. You're planning a trip to Mars. Before you leave, you spin a globe, close your eyes, and throw a dart. Wherever it lands, maybe a farmer in Nebraska, perhaps a child in Mumbai, that person dies of cancer so you can ride nuclear explosions to space. Would you still go? Dyson later explained their Cold War logic with chilling honesty. We were comparing this with nuclear war, where hundreds of megatons would kill billions. By those standards, a few statistical deaths seemed acceptable. But here's what those sanitized statistics really meant. Each ground launch required 800 to 1,000 nuclear detonations in rapid sequence, starting at ground level. Imagine setting off the entire Cold War nuclear testing program, concentrated in one spot in under 10 minutes. The radioactive cocktail wouldn't respect borders. Strontium-90, with its 29-year half-life, would settle into soil and accumulate in bones. Cesium-137 would contaminate crops for decades. Iodine-131 would concentrate in milk, targeting children's thyroids. The same isotopes that had driven mothers to protest atmospheric testing would rain down with every launch. Picture the milk recalls of the 1960s. Thousands of gallons dumped because of fallout from distant nuclear tests. Now multiply that by weekly Orion launches. Every glass of milk, every slice of bread, every breath of air becomes a game of radioactive roulette. By late 1959, this realization shattered Dyson's enthusiasm. The man who'd provided Orion's theoretical foundation now saw it clearly. They were planning to poison the planet one launch at a time. He considered even one death too high a price for reaching the stars. Therefore, the same year they proved Orion could fly, its chief theorist began backing away. Not because it wouldn't work, but because it would work exactly as designed, seeding death with every journey skyward. But fallout was just the appetizer to Orion's feast of horrors. The main course: mass-producing nuclear weapons like Model T Fords. Each pulse unit, Orion's euphemism for its propulsion bombs, was essentially a tactical nuclear weapon optimized for thrust. The spacecraft needed thousands. Think about that infrastructure. Assembly lines churning out atomic bombs with the efficiency of a Toyota factory. Warehouses stacked with enough nuclear devices to end civilization. Transport convoys moving nuclear weapons like Amazon packages. Imagine the proliferation nightmare. Any nation that developed Orion technology wouldn't just have a spacecraft. They'd have perfected industrial-scale nuclear weapon production. The specialized bomb designs for propulsion? With minor tweaks, they'd make devastating weapons. It's like developing a revolutionary new car engine that accidentally teaches you to build tanks. In March 1961, the danger became so clear that Vice President Lyndon Johnson personally seized every copy of the Gardner Committee report that had endorsed nuclear propulsion. He locked them in his personal safe, like they were nuclear secrets, because they essentially were. The report had revealed how Orion would hand any ambitious nation the keys to nuclear supremacy. Even the Air Force, not known for turning down powerful weapons, concluded Orion had no military value. But they'd missed the real threat. Orion itself wasn't the weapon. Orion was the excuse to normalize nuclear explosions, to make atomic bombs as routine as rocket fuel. Consider the precedent. If America starts launching spacecraft with nuclear explosions, how does it tell Iran they can't? If peaceful nuclear explosions become acceptable, where's the line? Today it's spacecraft. Tomorrow it's excavation. Next week someone's using nukes to mine asteroids, or to hold the world hostage from orbit. Therefore, Orion represented a Pandora's box that, once opened, would transform nuclear weapons from civilization-ending deterrents into everyday tools, a normalization that could never be reversed. Even if we swallowed the fallout, even if we ignored proliferation, there remained a problem that would make any engineer's blood freeze: controlling a barely contained nuclear chain reaction while riding it to space. The pusher plate, Orion's signature innovation, had to endure hell itself. Each nuclear blast would hit it with temperatures of 67,000 degrees Celsius. That's 11 times hotter than the surface of the sun, delivered in microseconds. The proposed solution: slather the plate with graphite grease between blasts, like you're buttering toast between hammer strikes from Thor. Tests with conventional explosives showed promise. But nuclear explosions play by different rules. Neutron bombardment would transmute the steel itself. making it brittle in unpredictable ways. One microscopic crack, one fatigue fracture invisible to inspection, and the next blast vaporizes your spacecraft, along with the 800 unexploded nuclear weapons still in the magazine. But here's the nightmare that kept even Orion's advocates awake: launch failure. Unlike chemical rockets that burn fuel as they rise, Orion would carry its entire nuclear arsenal from the ground. Picture this. You're 3 minutes into launch. 500 nuclear bombs already detonated, 500 more waiting. A shock absorber fails. The spacecraft tumbles. What happens to those 500 unexploded nuclear weapons when they hit the ground at supersonic speed? Best case, they scatter like radioactive confetti across hundreds of square miles. Worst case, sympathetic detonations create a nuclear groundburst orders of magnitude worse than any bombing in history. There's no abort system. You can't recall nuclear bombs mid-flight like you'd cut a rocket engine. Ted Taylor, Orion's driving force, would later confess, "We were captivated by technical sweetness. The whole thing had gone out of control. Massive. And very scary." Even success meant gambling with catastrophe. Statistical models showed that over multiple launches, catastrophic failure wasn't just possible, it was mathematically inevitable. Launch Orion 10 times, and you're playing nuclear Russian roulette with a partially loaded gun. Launch it 100 times for Mars colonization, you've guaranteed apocalypse. But perhaps Orion's most revealing failure wasn't in its engineering. It was in the minds that created it. To truly understand Project Orion's danger, we must examine the psychology of its creators, brilliant minds drunk on the wine of their own genius. Ted Taylor spent the 1950s at Los Alamos designing instruments of annihilation. During his daughter's birth in 1950, while his wife labored, Taylor sat in the waiting room drawing blast radius circles on maps of Moscow, frustrated that even his 500-kiloton super Oralloy bomb couldn't erase the entire city. He later recalled feeling possessive about his weapons. "My SOB, super Oralloy bomb, my bomb." This was a man who saw nuclear explosions not as humanity's darkest achievement, but as tools in his workshop. Freeman Dyson brought Princeton's prestige to this atomic fever dream, taking sabbatical to work on Orion. Years later, he'd admit, "We were all optimists. Sure, we could make it work." They ignored the uncontrollable, the unpredictable, the fundamentally chaotic nature of writing nuclear explosions. This wasn't isolated madness. It was systemic. The same era that birthed Orion also produced Project Plowshare, which proposed using nuclear bombs to dig canals, extract oil, and reshape continents. Edward Teller, father of the hydrogen bomb, wanted to nuke Alaska to create an artificial harbor. These weren't fringe ideas from crackpots. These were serious proposals from civilization's brightest minds. The atomic priesthood had developed its own morality, divorced from human consequence. In their equations, a statistical death was just a variable to minimize. Radioactive contamination became an acceptable trade-off. They'd become so intoxicated with solving technical problems, they'd forgotten to ask whether the problems should be solved at all. Years later, Taylor would write about his changes of heart, describing the slow realization of what he'd helped create. Dyson would call Orion the greatest moral failure of his career. But in 1958, that wisdom hadn't arrived. They were brilliant children playing with nuclear fire, convinced they could control the flames. Therefore, Orion represented peak atomic age hubris, genius minds so entranced by elegant equations and technical beauty that they nearly normalized the routine detonation of nuclear weapons as humanity's taxi service to the stars. On August 5, 1963, humanity collectively came to its senses. In Moscow, the United States, Soviet Union, and United Kingdom signed the Partial Test Ban Treaty, prohibiting all nuclear explosions in the atmosphere, outer space, and underwater. With the stroke of a pen, Project Orion became illegal under international law. The treaty's preamble reads like civilization's moment of clarity, seeking to achieve the discontinuance of all test explosions of nuclear weapons for all time, to put an end to the contamination of man's environment by radioactive substances. Within 2 years of the treaty's ratification, Project Orion was officially canceled. Freeman Dyson would later lament this as the first time in modern history that a major expansion of human technology has been suppressed for political reasons. Suppressed or saved? Consider what the treaty prevented. A world where nuclear explosions became routine, where every spacefaring nation needed thousands of atomic bombs, where radioactive fallout was the price of progress, where one engineering failure could destroy a continent. George Dyson's definitive history reveals that his father Freeman had already turned against Orion by 1959, convinced that even one cancer death was too high a price. The treaty didn't kill a dream. It prevented a nightmare. The ban forced us to find better ways. Chemical rockets took us to the moon without poisoning Earth. Ion drives now push our probes to the outer planets without splitting atoms in our atmosphere. We learned to reach for the stars without standing on a pile of nuclear corpses. Project Orion fascinates because it almost happened. The physics worked. The engineering was achievable. Hot Rod proved that nuclear pulse propulsion was more than theoretical. It was terrifyingly practical. We stood at the crossroads and nearly took the path to atomic hell. That's precisely what makes it instructive. Orion proves that humanity's most dangerous ideas aren't the impossible ones. They're the brilliant ones we're wise enough to abandon. As Ted Taylor learned through painful experience, there's a disease in nuclear fascination, a technical sweetness that can blind genius minds to monstrous consequences. Today, as we stand on new technological precipices, artificial intelligence that could outsmart us, genetic engineering that could redefine us, geoengineering that could break our planet's climate, Orion's lesson burns bright. Not every problem should be solved with the biggest hammer available. Not every capability should be pursued just because it's possible. The partial test ban treaty didn't steal our cosmic destiny. It proved we'd finally grown up enough to deserve one. By learning to reach space without nuclear explosions, we demonstrated that intelligence means more than solving equations. It means knowing which equations should stay unsolved. Sometimes the greatest achievement of human wisdom isn't what we choose to build, but what we choose to leave buried in the filing cabinets of history. What technology today will future generations view with the same horror we now view Project Orion? Are we pursuing our own Project Orions? Brilliant but terrible ideas we're too entranced to abandon? Comment below with your thoughts. If you enjoyed this story, hit subscribe for more stories where history, technology, and human ambition collide. Thanks for watching.